Hey, welcome to The Explainer. So let's talk about something that keeps every single data team up at night. How do we know our data is actually, well, good? How can we trust it? Today, we're going to dive into some incredible tools that help us finally tame that data beast.
You've probably heard this a million times, but it is the absolute truth. It's the core of everything we do. Think about it. If the foundation of your house is cracked, you're not going to trust the rest of the building, right? Same thing here. If your data is garbage, then your dashboards, your reports, your fancy machine learning models, they're all built on shaky ground. It's a domino effect that can completely derail everything.
So, what's the fix? How do we guarantee our data is solid? Well, the answer is actually to borrow a page from the software engineering playbook. You know how developers write unit tests to make sure their code works? We can do the exact same thing for our data. And lucky for us, there's a whole new wave of amazing open source tools designed to do just that.
All right, Section 1. Let's really get into why this isn't just a nice to have. The stakes for data quality are, frankly, enormous, especially when we start talking about machine learning. So when we say bad data, what are we actually talking about? Well, it's this stuff, the usual suspects, right? Missing values that just break everything, inconsistent formats, duplicate records, a total mess. But then there are the sneakier problems, like biased data that leads to really unfair outcomes. And my favorite, data drift. That's when your data silently changes over time and your once great model starts making terrible predictions without anyone noticing. It's a huge deal. We're talking wasted money, bad decisions, and even legal trouble.
Okay, but here's the good news. The data community has really stepped up to fight these problems. There are some incredible open source tools out there. Let's meet the big three, the heavy hitters in this space.
So here they are. Great Expectations, Soda, and Deku. Each one has its own personality, its own superpower. Great Expectations is kind of the all-in-one for Python lovers who want deep validation and awesome documentation. Soda is all about simplicity and scale, using these easy-to-write config files. And Deku? That's the beast for when you're dealing with truly massive data on Apache Spark. No matter what your stack looks like, one of these is probably a great fit. So let's pull back the curtain and see how these tools actually work. We're going to look at how each one approaches the problem, and yeah, we'll even check out some code. First up, Great Expectations. The name really says it all. The whole idea is that you define your expectations for your data. You're not writing complex logic, you're just stating the obvious in a clear, human-readable way. You're telling the tool, hey, this is what my data is supposed to look like.
And check this out. This is what it looks like in Python. It's so clean, right? You just take your data set and say expect column values to not be null for the email column, or expect column values to be between 1 and, well, whatever you want for the order amount. It almost reads like plain English, which is just fantastic.
But this is the killer feature for me. The output isn't some cryptic log file. It's data docs, a beautiful human-readable HTML report. It's automatically generated and always up to date. This becomes the one place your whole team, engineers, data scientists, even product managers can go to see in plain English, is our data healthy? It's a game changer. Okay, next up is Soda. Now Soda takes a different tack. Instead of being Python first, it's all about simple, scalable configuration files written in YAML. This is amazing for teams that have like hundreds of tables and just want a straightforward way to define checks without getting bogged down in code. So instead of writing Python, you just create a simple YAML file like this. This is using their language, SodaCL. You just say, hey, for my dim_customer table, I want to check that the missing count of birth dates is 0, and that the duplicate count of phone numbers is also 0. That's it. Super clean, super easy to read, and perfect for checking into Git. And then you just run what's called a Soda scan from your command line. It goes off, runs all those checks you defined, and spits out a really clear pass-fail summary right in your terminal. This is perfect for automation, you know? You can just plug this right into your CI/CD pipeline and fail a build if the data quality drops. And last but definitely not least, we have Deek. Think of Deek as the heavy lifter, the powerhouse for really big data. It was built by Amazon to work directly on top of Apache Spark. So if you're dealing with terabytes or even petabytes of data, this is the tool for you. With Deek, you're not writing separate config files. You're working right inside your existing Spark job, probably in Scala. You add these things called analyzers to your code. It's like you're telling Spark, hey, while you're processing all this data anyway, can you also calculate the size, the completeness of this column, and the mean of that one? It's super efficient and feels totally natural if you're already in that Spark ecosystem. And that's the key takeaway here. Deku doesn't make you run a whole separate process. It just piggybacks on the power of Spark itself. It validates your data while it's being processed, generating a quality report without ever having to move that massive data set around. It's all about efficiency at scale.
Okay, so we've seen the tools, but how do you actually use them in a real-world data pipeline? Where do they fit in, especially alongside something like dbt, which so many of us are using?
The best way to think about it is like setting up checkpoints or quality gates. Look at this flow. You put your first gate right at the beginning, after you ingest the raw data. This is where Great Expectations can step in and say, nope, this garbage data isn't even allowed in. Then you do your transformations with dbt, and after that, you place another gate to make absolutely sure that the final polished data is pristine before anyone uses it.
Now, this is a super important point, so listen up. People sometimes ask, doesn't dbt already have tests? And yes, it does. But dbt tests and Great Expectations are not competitors, they're partners. Think of it this way. dbt tests check your recipe. Did I follow the SQL instructions correctly? Great Expectations checks the final dish. Is this data actually good and ready to be served? You absolutely need both to have a truly robust system.
Okay, let's bring this all home. Why does this matter to you? Let's break it down by who you are on the data team. If you're a data engineer, this is your new best friend. It means no more 3 a.m. pages because the pipeline broke. You can automate all those annoying checks. If you're a data scientist, this is about trust. You can finally have confidence in your training data, which means better, more accurate models. And if you're a product stakeholder, this is peace of mind. It means you can actually stand behind the decisions you make because you know they're based on data you can count on.
And really, all of this is just one piece of a much bigger puzzle. It's part of this growing movement towards what we call data observability. The dream here is to have a complete 360-degree view of your data's health across its entire life cycle. No more black boxes.
So I'll leave you with this question. Your data is constantly sending you signals about its own health. When you put these tools and this culture in place, you're finally building the system to actually listen to those signals. You're going from just collecting data to having a real conversation with it. And that, right there, is how you build a future based on trust.